What's up, guys? In this lecture, we're going to discuss what's required to control the speed of a DC motor using an Arduino. Now, if you supply power and ground to a DC motor, it'll spin. If you swap which side gets power and which side gets ground, the motor will spin in the opposite direction. Now, you may think that all you need to do is use digital write on two pins, with one side being high and the other side being low. The problem with this is that the digital pins on an Arduino don't provide enough current to run a typical motor. In order to fix this problem, we're going to use a transistor. In a digital sense, a transistor acts like a switch. The transistor has three leads. Most of the electricity flows from the collector to the emitter, but this will only happen if current is flowing into the base. The base current is provided by the Arduino, and this current is enough to activate the transistor. Let's connect our circuit like this. We will need an NPN transistor. I'm using the 2N2222. We will need a 220 ohm resistor. Now, if you don't have a 220 ohm resistor, anywhere between 200 and 300 ohms should be fine. We will also need a small DC motor. I'm using a 3-volt motor. This will allow me to power the motor from the Arduino power rails instead of needing an external power supply. We'll also use a diode. This isn't required. However, it protects the Arduino and a transistor from negative voltage spikes that can occur when we remove power from the motor. Any normal switching diode should be fine. The diode only allows current to flow in one direction, the direction of the arrow. So when there's a negative voltage spike, the diode shorts out any reverse current. Be sure that the stripe on the diode is pointed towards the power side. Also be sure that the transistor is pointing in the right direction. In this circuit, the flat side is pointing towards me. It may be a good idea to power your Arduino through a wall connection as well as the USB. Depending on what motor you use, it may draw more current than your USB can handle. To control the speed of the motor, we use the exact same sketch we use to control the brightness of an LED. So let's upload that sketch to the Arduino. Depending on the voltage rating of your motor, it may not start by itself if you're running off the Arduino power supply. You may need to give it a spin or increase the power to maximum to get it to start rotating. You'll notice that the motor doesn't really do anything in the range between probably 0 to around 100 at the beginning. If you wanted your motor to always spin, you could change the map function and start at 100 instead of 0. Let's go ahead and do that. Now we can see that the motor is always spinning. We can increase the speed and slow down the speed. That wraps up our third project. To recap, now we know how to use a potentiometer, use the analog write function to send a PWM signal to both an LED and a motor, and use a transistor as a digital switch. See you guys next time in the fourth project. Peace.